Every day, giant machines cross the sky.
It can look as if gravity forgot about them.
A passenger airplane can weigh hundreds of tons. But it does not simply fall. The answer is a balance of invisible forces. In this video, we turn those forces into pictures. Start with the whole airplane negotiating with the air. Lift pulls upward. Weight pulls downward. Thrust pushes the airplane forward. Drag pulls backward against the motion.
When the forces balance, the airplane can climb, cruise, or descend smoothly. So the real question is, where does lift actually come from?
The answer begins with the wing.
Zoom in, and the airplane becomes a machine for shaping airflow.
Air above the wing behaves one way. Air below the wing behaves another way.
A common story says the top path is longer. So the air must move faster, but that is not enough. That story is too simple.
A better picture is pressure plus air being bent downward. Wing shape, angle of attack, and airspeed work together. The result is the upward force we call lift.
Pressure is invisible, so imagine the wing inside a wind tunnel.
Where air speeds up and turns, pressure can become lower. Above the wing, lower pressure helps pull the wing upward. Below the wing, higher pressure helps push the wing upward. That pressure difference spreads across the wing surface. Small pressure over a big area becomes a huge lifting force.
This is one half of the lift story. The other half of lift appears behind the wing.
The wing does not just sit in the air, it redirects air. When air is sent downward, the wing is pushed upward. That is Newton's third law, visible in the sky. Lift is a combination of pressure and momentum. The airplane stays up because air is constantly redirected.
Now the airplane needs forward motion.
Forward motion is the engine's job. A jet engine throws air backward. Cool air enters the front fan. The compressor squeezes the air and makes it hotter. Fuel burns in that airflow and adds energy. Hot gas blasts out the back. The reaction pushes the airplane forward. Thrust creates the airflow. The wing uses that moving air to make lift. During takeoff, the runway turns engine power into airspeed. More speed means more air flowing across the wings. The pilot raises the nose. That increases the angle of attack. Lift rises until the wheels no longer need the ground.
The airplane climbs because thrust, speed, and wing angle work together. But flying is not only climbing, it also requires control.
Pilots steer by changing airflow around movable surfaces. Ailerons roll the airplane left or right. The elevator raises or lowers the nose. The rudder swings the nose left or right. Flaps increase lift and drag at lower speeds. Small surfaces make a huge machine controllable.
The airplane is guided by shaping the air around it.
In cruise, the airplane is not violently fighting the sky. It is holding a careful balance. Lift balances weight. Thrust balances drag. Trim and autopilot help hold that balance for hours.
Smooth flight is precise balance, but air is not always calm and smooth.
Turbulence means uneven moving air reaches the airplane. For a moment, airflow speed and direction change. The wings may flex. The airplane may shake. But the physics is the same. Airplanes are designed to respond and bend.
Then they return to stability. The final challenge is landing safely at lower speed.
Landing is a controlled trade. Less speed, more drag, and accurate lift. Flaps extend. Now the wing can still make lift at lower speed. The landing gear comes down and adds drag. The pilot follows a smooth path toward the runway. At the end, flight speed becomes gentle contact with the ground.
Now the whole story of flight fits into one picture. So why does it not fall?
Because the wing shapes and redirects air. The engines create forward motion. That motion keeps air flowing over the wings. Control surfaces guide the airplane through moving air. Balance keeps everything stable from takeoff to landing.
The sky is not empty. It is a medium that can be used.
That is the science of how airplanes fly.